Altitude.
Greetings, everybody, wherever you may be, and welcome to Kourou, the home of Ariane, for tonight's live broadcast of Arianespace flight number 155. We're in the Jupiter Mission Control Room, where the key players in tonight's launch are going through the motions as operations continue in the final moments of the final countdown. Commentators tonight in French, Germaine Dagonier and Laurent Jourdain. And in English, I'm Joshua Jample. With me, Suni Abramson. And you can also follow the broadcast tonight on our website, arianespace.com. All right, well, welcome back to Flight 155, Take 2. We are green. That's the first thing we want to tell you. We're fine and we're in good shape. We're counting down. But we do want to go right away to Suni, who's going to give us a rundown of what happened ever since we left you last night, roughly sometime after 8 p.m. Kourou time.
Yes, as you know, we had a stop in the countdown due to an anomaly in the dialogue between the onboard computers and the ground computer checking on them. After a thorough investigation, they found out that the problem was not of any risk, and it was decided to continue, resume the countdown. Unfortunately, this was very late. We had gotten an additional 15 minutes launch window from the passengers, and we were 2 minutes late approximately in that, and Arianespace therefore decided to stop the launch yesterday.
The same crew, the mission director, Mr. Pigonier, and the same DDO as last night, Jean-Yves Trabaul. Now, this extension on the launch window, is that a normal occurrence?
No, it rarely happens because the 45 minutes is the Arianespace standard launch window. Sometime.
À tous de DDO, attention pour le début de la séquence synchronisée.
All right, that's normal happening. DDO is going to announce the beginning of the 7-minute mark. You'll hear him call out 7 minutes. That's the beginning of the synchronized sequence.
Top H-7 minutes, début de séquence synchronisée.
All right, that's the automatic sequence. We're into the computers shifting over, taking over power. We'll get back to an explanation. We want to finish the. We had an extension of the launch window.
Yes, and that is not easy for the satellites. They have to eat into their margins where they have, and might get difficulty with electric power or pointing when they get into orbit. So it's not an easy decision for them.
Was the launcher drained? Did we have to drain out the...
yeah, it was defueled.
It was defueled.
Yeah, and they will see, so get detail again, among us 5 veterans from the early Meteosat, we're still here tonight again.
How long does it take to drain the launch? And which stage? It's only the cryogenic stage.
It's just the cryogenic stage, and it takes several hours to do.
Okay, we'll get back to that. Over to Christophe Bardou now on a description of the mission tonight.
Tonight's Ariane 5 launch vehicle for V155 will show once again the tremendous flexibility and versatility of the Ariane 5 system. We're carrying aboard 2 payloads with very different missions. Under the fairing, tonight's version measures 12.7 meters. Our Atlantic Bird, a telecommunications satellite for arianespace, which will be in service with Eutelsat. Under the Silda 5 carrying structure, we also have MSG-1, a weather satellite. The launcher has 1,200 tons of thrust at liftoff. The major part of this is provided by the 2 solid rocket boosters during the first 2.5 minutes of flight. This performance allows us to inject the 2 payloads into geostationary transfer orbit. This flight has an apogee of 36,000 kilometers, a perigee of 580 kilometers, and an inclination of 5.5 degrees with respect to the equatorial plane, instead of the 7 degrees normally provided by Ariane 5. This reduction of 1.5 degrees means longer life for the satellites. The energy needed to circularize the orbit has been reduced by the additional performance from the launch vehicle. The launch window for V155 begins at 19:30 Kourou time, at 22:30 Universal time, and lasts for 45 minutes.
All right, well, you see, you saw the 7-minute, the red strip there while you're watching the interviews. We're back to a red on the, what is that, the launch base?
It's the same as yesterday, same area as yesterday. It's the launch control center.
Also called the CDL, right?
The CDL. And I have not yet gotten any information on what might have happened.
Yeah. So we're stuck again, folks. And you see that the clock has gone back to the 7-minute mark, because if and when the problem is solved, we will have to start the clock again at the beginning of the synchronized sequence, which was 7 minutes, minus 7 minutes.
And this happened a bit faster than last time, which hopefully will be a shorter stop in the countdown than was yesterday.
Well, let's finish the update. Last night the launcher was drained, and how long does that take?
Some hours, 4 or 5 hours, and that is something that you have to do, because one of the things we talked about the greens yesterday was the weather problem. Tonight there is no weather problem, but if you have a weather problem, which is I think the most frequent reason for a delayed launch, you need to be able to defuel. So for the people doing it here, it's a routine event.
Now you have to defuel. Why would that be? It's dangerous liquids, or it's corrosive liquids, or what?
No, not at all. You've got oxygen and
hydrogen?
Liquid hydrogen, and they are super cool propellants, which means that they boil off all the time. They are not in a natural, they need pressure, not in a natural state, which means you have to go on topping up, letting out the gas, hydrogen or nitrogen. Hydrogen is let out in a pool, because hydrogen together with oxygen is dangerous.
So is that why you have to defuel?
That's one reason. No, the main reason is because you go on topping up all the time. You're going through a procedure, and you gain nothing by it except keeping the people tired.
Is the main cryogenic stage fueled, topped up until pretty close to liftoff time?
Oh yes, you want to have an optimum filling of the tanks, which means that you go on. You have a cyclic pressurization sequence where you fill up to a certain level. You have let out it. Now the pressure goes up. You let out and you fill again.
This is the same procedure as the Ariane 4 third stage.
Yes.
Which was also cryogenic.
Exactly.
Cryogenic fuel, liquid hydrogen and liquid oxygen.
Yeah. And I've been on many launches where there's been weather problem, and you might refuel the drain and refuel several days in a row, and the only problem then is the production of liquid oxygen, liquid hydrogen. Here for an Ariane 4 it's not a difficulty, as it's only a 10-ton fuel capacity.
This is 10 times.
That's 10 times
10
it.
times.
So, but there is at least a backup for one day. As you know, we're here the second day, and it's then empty tanks are being refilled. We produce the liquid oxygen, liquid hydrogen here in Kourou, so it's nothing being imported. The factories are out very close to the launch base.
For the Ariane 5?
For the Ariane 5, yes.
Yeah, this was a first in the Ariane 5 program, as I understand it, because did we produce the liquid hydrogen and oxygen here?
Not in the beginning, but when the system was ready, it was produced here in situ. The factories were built for the Ariane 5.
And there is the Ariane 5 waiting on the pad. For those of you unfamiliar with the launcher, a thumbnail sketch, as long as we have a nice shot there, it's in two parts. They call them composites, a lower composite and an upper composite. The lower composite comprised of the core cryogenic stage that Suni was talking about, and the two boosters. You can see the booster in the foreground there. And you can see the two boosters there. And the upper composite is the what they call the EPS, the upper stage, which consists of a single engine stage and the satellites.
Yes, and the EPS has a totally different propulsion system.
And the EPS is going through some upgrades. The whole Ariane 5 is going constantly through some upgrades, and we'll get back to those when we have when we have a minute, and bring you up to date on those. We're still waiting for some information. We have absolutely nothing to tell you, unfortunately. We're waiting for, excuse me, we're waiting to hear if we can pick up the countdown. We got stopped when we had just gone into the synchronized sequence a minute or so. A little earlier than last night, right?
Which is very good, because as we talked about last night, the later you are after the 7 minutes, the more painful it gets to reconfigure back to 7 minutes and start all over again.
So the various crews, the arianespace people and the satellite people and the CSG people, again, like last night, checking out the parameters and looking over the situation. And
with the information we have, which is that it is a very, not the same problem, but it's a similar problem of verification of a parameter.
So as soon as we have some information, we'll of course pass that along to you. We're waiting for the DDO to announce a recommencement of the countdown. We're holding at minus 7 minutes. Meanwhile, in the launch center, the launch directorate is going over the parameters and analyzing what's up. And then the launcher will get back into launch configuration.
Yeah, we maybe
ready to go.
Recall what we talked about yesterday, that we have the flight directorate here, which has the ultimate decision to go ahead. This in a case they are there to take the decision if something unplanned happens. And this is it. It happened yesterday, and there is an unplanned event today. Then we have a number of experts at the Launch Control Center, the CDL. They have access to experts also from EVRY in France. So there's a lot of people being able to address the problem.
Experts in EVRY, France, and across Europe, I imagine, as well.
If need be, yes, from whatever manufacturing source the equipment comes, or the program. And it's expected that we will start within not too long time.
The word says that we may be going, but we're waiting for confirmation of it. The structures that look like radio towers surrounding the Ariane 5 there, what are those?
Those are lightning towers to protect. You have, of course, liquid oxygen and liquid hydrogen mixed together are explosive. You have explosives in the solid boosters. You have electrical ignition and so on, which means that you need to protect the launch vehicle from being hit by lightning, and that's why we have the towers. We are French Guiana is not a very difficult place.
No earthquakes, no hurricanes.
No hurricanes, and not a very bad thunderstorm country either. Yeah. Generally, this is a period, the dry season, when you have more of the thunderstorms, but inland, because you have convection over the...
Rain is not a problem, though, for a launch, usually, which is good, because we're in a country where there's not one, but two rainy seasons. There's the sort of a major rainy season, and in case that weren't up, there's sort of an auxiliary backup rainy season, which is sort of a minor rainy season from November all the way around to June, I think, roughly. So there's a lot of rain, but the rain doesn't usually stop us from going. It's the lightning that can do it. Yeah.
Lightning is one factor. You have... when we talk about the weather, you have wind speed. The launch vehicle can withstand a certain ground wind.
And upper atmosphere winds too, I recall.
As well for wind shear reasons, because you have up top you have the jet stream, and that changes from time to time direction, and it might give you wind shear effects at fairly high altitude. On the ground as well is for safety reason, as you have the boosters and also the satellites contain
what they call hazardous
fuels, and we need to be sure that if something will happen in flight, it will not affect the surrounding areas.
So the major rain is not a problem. Lightning can be a problem, and winds can be a problem.
Yeah. We don't have cloud height.
Visibility.
No cloud height, because if you have a very thick cloud, the sheer disturbance of the launch vehicle with a hot jet might cause lightning. So there's a limit to the cloud height. Heavy rain can temporarily be a problem due to visibility. We have, as you can see, with the launch vehicle, you have
the cloud ceiling here must be higher than 250 meters. Is that,
yes, 250 meters. Right? That is because from ground to 250 meters, the radar does not work very well due to ground echoes. So we have a visibility of the trajectory during the 250 meters. Mm-hmm. So that's cloud. Cloud needs to be higher ceiling. Than that.
Yeah. And how about horizontal visibility?
Horizontal visibility. You need to see the launch vehicle from where the cameras are, and they are some distance away.
And why? Now that is just for the archives for every launch. We need
for safety. Again. We need to ensure you have tracking to ensure that you know where the launch vehicle is at all times, because it's not allowed to deviate too much from that trajectory.
So certain conditions, I mean, we can launch in most weathers, but not in any weather, but certain conditions have to be met, the wind speed, as you said, and the horizontal visibility for the tracking cameras and the cloud ceiling. And we don't really fear, Ariane doesn't fear rain too much. No. Would we say that? No, we can launch pretty much in rain.
It's,
but lightning can be
lightning, yes.
Well, tonight that's not a problem. The weather is as green as it can
wonderful, be. Yes. We're in the beginning of the dry season, and there's been a rain just before we came, I believe.
There's been a little more rain than the usual dry season in my memory. I don't go back too far, but I wonder if this might be the El Nino effect with the crazy weather and the floods in China and the floods in Europe and the drought in the western part of the U.S.
À tous DDO, retour vers des ensembles de lancement. Tenez-vous prêts pour une reprise du décompte.
Okay, well, we've gone back to green, 7 minutes. You can see it there. DDO says imminently we will go, and there we are.
There we start.
We're gone again. We're underway.
And à tous de DDO, la nouvelle heure de tir est 22h45 minutes 10 secondes.
So we're going to launch at...
We have a new launch time at 10:45 local time.
No, 10:45 right? Universal time.
Universal time.
And we're launching at 7:45
local time. Right. Now what...
And 10 seconds.
What changes that? What was the original...
It changes with 15 minutes.
So we have a 15-minute...
delay in the launch.
Yeah, okay.
And we have another 30 minutes of launch window. So.
All right. Well, we're back in... We're back in business. We're counting down in the synchronized sequence. Now, did we get into much of an explanation last night of the synchronized sequence? We got down maybe 3 minutes worth.
Yeah, the synchronized sequence is what caused the problem yesterday as well. Is that there are hundreds of orders given to get the launch vehicle into flight configuration. Most of them are being done by the onboard computer.
There are too many orders for human hands to do.
You would never. We could do that.
Not in 7 minutes.
We would have to start much earlier to do that, and it might not be technically feasible, as many orders will have to come in a rapid succession, and above all, you need to know rapidly what's happening as well. And
you were saying the computers are taking over all the. Vital systems being checked out, everything to ensure the safety and the success of the launch. Philippe Grimaldi, the same crews as last night.
Exactly. Yes. No need to change it. They did rest, and they started the preparation, the countdown, the same thing as they did last night. They might have, well, yesterday morning, they might have shortened it, but for also minimizes risk, they started the same procedure following the same all the steps as yesterday.
So we are checking out everything. What are some of the other things that are happening right now before, in this 4 minutes before liftoff? The satellites are being armed, which means they're going on their own power?
They are ready to go. They're even on onboard power, and they were on onboard power about 20 minutes before. They have, we mentioned it yesterday, battery capacity to stay through the whole launch window on board power. So they are just waiting. The satellite teams at the test center for the preparation center for the satellites are monitoring the satellites and telling the mission director Sergio Rota here for EUMETSAT and Filippo Grimaldi that everything is all right.
And everything is all right. You can see the green status panels up are green. Our reds are gone. We're coming up on 3 minute mark. And this is roughly where we got stuck last night. And we have shots coming up for you of the rollout, which took place yesterday.
No, the day before yesterday.
The day before yesterday.
Where
roughly 24 hours before launch.
24 hours before. No, it's gone in the morning, so about midday the day before the launch.
Rolled out. Well, you'll see those shots coming up. The launcher moved out of the final assembly building, and also called the BAF, the BAF, the final assembly building, and rolled over to the launch pad.
Yes.
On a rail track.
And we should have had it here, but it's not coming, so we still follow down. We're down to less than 3 minutes. And here we'll have the rollout. And I went out there. It's a pretty fantastic sight.
It's a great sight. When you go by the road, before they close the road, you can see when the gates are open, you see the launcher there. And then this is they rolled it out of that final assembly building on the rail track, as you can see, a couple of kilometers from the building over to the pad, being pulled by what? A single truck?
A single truck, yeah, which has very low gears. The maximum speed is 4 to 5 kilometers per hour. And, it's a heavy load. It's 1,500 tons. 870 tons is the launch table only.
It's sitting on what they call the launch table, and it's still sitting on the launch table when it's out on the pad. That's one of Europe's heaviest structures. It's the second heaviest structure in Europe in the world. It's 500 tons. With the launcher, it's what, 800?
The total with the launcher is 1,500 tons. And it's beaten actually by the gantry on the Ariane 4 site, which is 3,000 tons, which is the heaviest structure in Europe, because we are in Europe here.
1 minute and 30 seconds. You can see the Ariane Flight Directorate, Jean-Yves Le Gall on the left, and Mr. Perez on the right. He's a technical director, I believe. Huh?
He's a technical director responsible for technical matters of the Ariane.
DDO, attention pour H-1 minute.
Coming up to the 1 minute mark, you'll hear the DDO call that out.
And we now have the launcher is armed. And we have pressurized the tanks.
All right, we're into the final minute. One minute to go. Just an interesting note on the shots of rollout. There are 20 drivers who are qualified to work here on the space base to pull the various structures around. Only 4 of them are qualified to drive the truck to pull the launch table, and they have to have done a minimum of 5 launch campaigns before, and they take 1.5 years to train them. You'll hear the DDO call out the final moments of final countdown. We'll leave you
À tous de DDO, attention pour le décompte final.
And we'll see you back after Ariane has lifted off. Enjoy the liftoff, everybody.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top. Mise à feu, Vulcain. Décollage.
In a burst of bright orange lights, always a spectacular sight. Ariane rising up into the sky. You see her rise vertically about 6 seconds. Then she turns over to get the radio antennas facing...
The radar antennas facing the ground antenna.
Everything is normal, the DDO is saying. It's a beautiful night. The people on the beach and lining the roads in and out of the Space Center, treated to quite a spectacle.
Another sound is reaching it here as well. It's taken all this time to go the 13 kilometers, 1 minute.
The core stage and the two boosters are burning. The core stage 100 tons of fuel, and each booster with 540 tons of fuel. The two boosters providing 90% of the thrust. Ariane could not lift off without them. The core stage is not sufficient. It's not enough.
Also only 10% of the total lift-off thrust. But most of the lot of lift-off thrust is also to carry the boosters, so giving you the speed.
Ariane is not going up and down. It's the picture is she's flying over our heads, and the cameras are following her that way.
And going almost due east from here.
And out over the Atlantic, where she'll be crossing, take about 15 minutes to get across. We'll be tracked by the ground stations. We are underway.
And on the screen we can see that the boosters have finished very soon.
The boosters burn for about 2 minutes. You should be able to see them. This is we're tracking with the naked eye now. This can see how bright the boosters.
There is the...
That looks like a flame out.
And they have
been jettisoned.
separated.
There they are. You can see them falling away.
Yep.
From the launcher. They will fall in the Atlantic. They can be recovered, but they are not often recovered. They're recovered for analysis purposes.
Yes, sampling on a periodic interval. Then we need to have a mass penalty due to parachutes and so on.
But they're not reused ever, are they?
Never reused. And at this time, there are 3 segments, and each segment is opened up by a charge after 20 seconds, so they won't float around on the sea. They will sink.
All right, on the lower left-hand corner of your screen, we see some figures there. Can you explain them to us?
Yes.
Meanwhile, the DDO says everything is normal when you hear his voice.
And we are already reached the fairing separation while we're talking here.
This is what happens up there. The fairing separation, like the booster separation, is done with the minor explosives, pyrotechnic cords.
Yeah, pyrotechnic cords. All separations are done, even between stages, by pyrotechnic cords, one form or another.
And we drop we release the fairing now because it's extra weight that we don't need. It can be up to 700 or 800 kilos. The fairing is sort of like a flying clean room. It keeps the satellites from acoustical problems and weather problems and vibrations.
Aerodynamic form.
And vibrations on liftoff too. All right. How about the numbers there on the lower left?
Yes. Well, we have the Moyenne CIS. That is a redundant computer on board, which is actually giving the data down. That's why the SV has 0 degrees. It's not a tracking station on ground which is following the launch vehicle. We're getting the quick look data.
All right, we'll come back to that. We're going to go over to Bernard Puy-Grenier now to give us a rundown on double launches.
The satellites were prepared during the 155 launch campaign, which is just ending. Atlantic Bird 1 was entirely prepared in this zone, and MSG-1 was partially prepared here. MSG-1 arrived in mid-May and was prepared in S1, then transferred here to S5A in this building just behind me for filling. Atlantic Bird 1 arrived here in mid-June. Its preparation campaign began in S5C and it was filled in S5B. These operations were completed a few days ago, since we are now in the combined operation phase with the launcher. The two satellites were transferred to the final assembly building at what I would call a startup phase for S5, because we had Envisat here, which is a big satellite, and needed particularly large facilities. This phase is now over, and we have reached our operating rhythm. The two satellites from the last flight, 153, we are here, Star 5 and in Star C. Then we had the two satellites from tonight's launch, V155, Atlantic Bird and MSG-1, and we are waiting for Intelsat 906, which will be the passenger 154. We have reached our cruising speed, the rhythm this building were built for. If we use the two launch tables, we can schedule launches even closer together with no problem at all. Since these facilities let us treat up to 4 satellites at once, we can run 2 double launches in a row quite close together. If necessary, we can also use the older satellite buildings, which are still in service in the technical center. We can prepare satellites there. And we also have the A3 dome, which can be used for filling. We can work on 4 satellites in this complex, in 4 totally independent work areas. You could almost call them 4 totally independent apartments, where each customer can have their own setups necessary for the preparation of their satellites. There are 4 independent offices in 4 independent control rooms, each with its own independent access. The clean room itself is a big room separated in 2 ports. We have 2 filling rooms which are totally separated one from the other. Arianespace's main concern in designing these facilities was maximum simplification of the heavier phases. We wanted to bring a maximum amount of comfort to the customer in their day-to-day lives on the base during their launch campaigns.
Pas un peu lourde et je dirais apporter un maximum de confort au client dans sa vie sur le site ici pendant sa campagne de lancement.
All right, there's Bernard Prigonier. He's his 12th launch as mission director. You were interrupted by the film. Go ahead.
Yes, so we've already reached an altitude of about 137 kilometers. We're in a flat part of the curve. It's actually we're getting a lower altitude due to the optimization of the propulsion between the thrust and the mass of the launch vehicle at this stage. And but the speed is increasing all the time. We've got 5.48 kilometers per second.
5.5 kilometers per second, and the speed we need to separate a satellite is
9.1 kilometers per second. So
9.1. So we're more than halfway
there in speed.
Good. You're watching Arianespace Flight 155, and we're coming up. If you look at your screen on the upper left-hand corner, you can see the cursor moving up to, I don't know if you can read that, but it says SEP EPC, which is separation of the EPC or the core stage. And
we have approximately a bit more than a minute to go.
That will be the end of the first half of the mission. We mentioned the Ariane 5 is in two components, a lower and an upper. You can see the track here of our downrange stations. We're being picked up by the first downrange tracking station in Natal, which is over the border in Brazil. The Ariane 5 trajectory designed to ensure the launcher always visible from the ground station tracking it. And it's tracked here at Kourou, then at Gallio, which is also in French Guiana. And the first downrange station out of the country is at Natal. It's a station run by the Brazilian Air Force.
We have a fairly optimal overlap here of about 15 seconds between we leave Kourou station, and Natal takes over.
Which is normal. You'll hear the DDO say, we've lost the signal from one station, but it doesn't mean we've lost the signal entirely, because we're still being tracked, as you say, because of the overlap.
Yeah.
All right, we're coming up, as we say, to the end of the core stage burn. That'll be the end of the lower composites mission, and the first half of the Flight 155 will be over, and then we'll be concentrating more on the satellites. You can see our altitude 150 kilometers, and our speed approaching 8 kilometers per second.
And here we have the separation of the first cryogenic stage.
The burnout of the core stage.
Yeah. And you can see in the image the cut of the skirt between the EPC and the EPS, and that's a pyrotechnic cord.
And the ignition now of the upper stage, that's an engine that is a little different than the engine in the core stage, isn't it? The Estes engine, it's called.
It is. It's very similar in design to a satellite engine. Fewer moving parts. The fuel is pressurized by helium to go into the igniter in the injector in the engine, and when the two propellant meet, they ignite spontaneously, and that's called hypergolic.
All right, the EPC, what happens to that? It's dropped into the Pacific. I think it makes a half turn around the Earth, but before it's dropped into the Earth, it has to be
passivated.
Which
means that you have liquid hydrogen in one part and liquid oxygen, and you have still some residual propellant. Due to that, we have to go to an exact time to stop, and to avoid from the gases to destroy the bulkhead in between them, we open valves and let the gases out.
This is called passivization.
That's called passivization. Passivation. Yeah.
And then the EPC will drop into the Pacific near, but of course not on, the Galapagos Islands.
Yes, it's going almost
all the way around
the world.
All right, the upper stage now holding 10 tons of storable propellant. That's in a way like the Ariane 4, but it's different also. The third stage, the top stage of Ariane 4, had 10 tons, but it was a different propellant, wasn't it?
That was the same as the cryogenic stage, the first stage here. And as you mentioned yesterday on the Ariane 5, the 10 tons.
All right, we've been picked up by the second downrange tracking station after Natal, which is at Ascension Island out in the Atlantic. That's an ex-NASA station and operated by UK Cable and Wireless people. We'll record the telemetry, the basics of the telemetry, and then relay them back here to Kourou. What would you say the mission of the upper stage is?
The upper stage mission is to place the passengers in the right